Hi class, we are starting a new unit on congruence and similarity. And today we are going to do part 1 of lesson 9.1, and those are problem numbers 1 through 5. We will do the second half of 9.1 later. Before we get really into it, there are a few things that you need to understand. So I wrote a few notes on congruent figures, and I want to go over that now. Congruent, what that means is the exact same shape and the exact same size. So, and it doesn't matter how you turn it or flip it or move it. Two figures are, if they are the same size and same shape, they are congruent. This is the symbol for congruent. So if I write triangle ABC, and then I've got that sign and triangle DEF, it is saying that triangle ABC is congruent to triangle DEF. All right, there are some things we need to go over about properties of shapes, and there are tests that can prove whether triangles are congruent. And I want to go over those tests now. This is for triangles. One is called SSS. This stands for side, 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 side. If all three sides are the same length, then the triangles are congruent. The other test is SAS, where S stands for side, A stands for angle. So this is the side, angle, side test. And if two sides are the same length and the angle between the two sides are the same measure, then it is congruent. Then the two triangles are congruent. So you can look at all three sides. If all three sides are the same length, then they are congruent. Or you can look at two side lengths with the angle in between. If the two side lengths are congruent and the angle in between are the same measure, then the two triangles are congruent. The other test is angle, side, angle. So if you have two triangles and two angles are the same measure and the side between the two angles are the same length, then the two triangles are congruent. And the last test is RHS, which stands for right angle hypotenuse side. So if both triangles have a right angle and the hypotenuses, I don't know if that's the right word, but the hypotenuses are the same length and one of the sides has the same length, then the two triangles are congruent. So 4 tests for congruence of triangles: side, 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 angle, angle, right angle, hypotenuse, side. If you've got those that are the same, then the two triangles are congruent. Now, the other thing I wanted to talk about are some properties of quadrilaterals. And again, a quadrilateral has 4 sides. So some properties, if the opposite sides are the same length, this is true for parallelograms, rectangles, rhombuses, and squares. So opposite sides, what we're talking about is like the top and bottom, and the left and right. So if the opposite sides are the same length, or if it is a parallelogram, a rectangle, a rhombus, or a square, we know that the opposite sides are the same length. Opposite sides are parallel in parallelograms, rectangles, rhombuses, and squares. If you have all sides that are the same length, that is true for a rhombus and a square. And then there's a shape called a kite. And a kite has adjacent sides that are the same length. So the two sides that are touching, are the same length. And we'll look at those in our problems. All right, let's get started on page 57, 9.1. And we're going to do several together, and then I'm going to have you finish on your own. All right, let's look at this. It's lesson 9.1, Understanding and Applying Congruent Figures. And it says, name the figures that are congruent, name the corresponding congruent line segments and angles. Okay, so this says that triangle ABC is an isosceles triangle, and M is the midpoint of BC. So this is BC, this is a line segment. If M is the midpoint, that means that BM is the same length as CM. It cuts it in half if it's the midpoint. Okay, we also know that this is isosceles, and isosceles triangle has two side lengths that are the same length. And we can tell that AB and AC are the same length. We know that because of these two hash marks. Okay, so let's get started. We want to name the figures that are congruent, name the corresponding congruent line segments and angles. Okay, we said that M is the midpoint. So that means that BM and CM are the same length. So I put a little hash mark there. So these two are the same length. These two are the same length. And then we've got this side here. Now this side divides our isosceles triangle into two triangles. So we've got triangle BAM, this is one of our triangles, and we've got triangle MAC. Now we can figure out that they are congruent. And how do we know? Well, we know these two side lengths are the same length. We know that these two side lengths are the same length, and then they share this side length. So this side length is the same length, okay? So we know that triangle, I'm gonna write this, triangle BAM is congruent to triangle MAC, okay? And how do we know that? What did we use to prove it? Well, we used these two side lengths are the same length, these two side lengths are the same length, and then this side length is the same for both. So we use the SSS test, the side test. Now we need to, it said name the figures that are congruent. We've done that. Those two triangles are congruent. Name the corresponding congruent line segments and angles. Okay, so let's look at our line segments. So in BAM, BM is congruent to MC. We use the little hash marks to show that. So BM, whoops, is congruent to MC. What are the other side lengths that are congruent? Well, BA is congruent to CA. Okay. And then AM is congruent to AM. They both share that side length. Okay, so the three side lengths are the same length. And if they're congruent, that means that all three angles are the same measure. So we've got to talk about congruent angles. Well, we can tell this angle, AMB, is congruent to AMC. So we're going to use angle AMB is congruent to angle AMC. And I want to, before we go on, just acknowledge that all of these, you can turn these around and it be the same thing. Like line segment BM is the same thing as MB. If you turned it around and wrote MB, we're talking about the same thing. So you could call it by either name. Now, angles are a little bit different. There are two names for this angle. I could call it AMB, or I could call it BMA. So either name is fine for this angle. Same here, AMC, I could go backwards and call it CMA. So the naming, I'm just using one of the names, but there's another name for this. Okay, so I did these angles. We know that these two angles out here are the same length. And so this is ABM is congruent to ACM, angle ACM. And last but not least, we've got these two angles here. And actually, this line bisects this angle. That means it cuts this angle into two equivalent ones. So BAM and CAM are the same length. Angle BAM is congruent to angle CAM. All right, so we had two triangles. We told the corresponding side lengths, and we told the corresponding angles. All right, let's look at number 2. ABCD is a parallelogram, and AP is equal to CQ. Okay, so we've got AP and CQ are the same length. They've got the little hash marks to show that. Now, one thing about a parallelogram, opposite sides are the same length. So that means AB is the same length as DC. So if this part and this part are the same length, these two little parts have to be the same length, okay? So I'm going to put a single hash mark to indicate these are the same length. Now, we also said opposite sides are the same length. That means that AD and BC, they're opposites and they're the same length. So I'm going to put little 3 hash marks, okay? And then we've got this one here. So if we've got if we've got this parallelogram, another thing about parallelogram, opposites are this angle here and this angle down here, they're actually the same length because it is a parallelogram, or the same measure. And then B and D are the same measure as well. All right, so let's talk about if we've got this, we have two quadrilaterals. They're no longer parallelograms when you mark this. Okay, and so this is quadrilateral PADQ, or I could call it ADQP, or I could call it DQPA. It doesn't matter, you just have to be in order, or I could go back, PADQ. There are lots of names for this quadrilateral. This quadrilateral and this quadrilateral are actually congruent, because if I were to take this one and imagine this is like a little hinge and you were to flip it over or turn it along this hinge, these two would line up, these two would line up, and these two would line up, and then they share this side length. So it is congruent because it has 4 sides that are the same length. So the two quadrilaterals that are congruent is I'm just going to go APQD. APQD is congruent to CQPD. CQPD. All right, so there are 2 quadrilaterals, so there are 4 sides and 4 angles that are congruent. All sides and angles are congruent. Okay, so let's do the side lengths first. AP is congruent to which one down here? Well, we wrote it CQ. That's one of the side lengths. The short side lengths, those are congruent. So we're going to say PB is congruent to QD or DQ, whatever you want to call it. And then these are congruent. So that is AD is congruent to CB. And then we've got this one that's the same. So PQ is congruent to PQ or QP, whatever you want to call it. All right, so the 4 side lengths, we've got the corresponding side lengths and then the same length. Now we need to imagine the corresponding angles. Okay, so we already said that these two are congruent. So if I were to turn this over, angle C and angle A would sit on top of each other. So, but I'm going to call them by its full name. So we're going to say PAD, angle PAD is congruent to angle BCQ. Okay. Then we've got this one here. I don't know how to differentiate. B and D are congruent. So we need to write those. So we've got ADQ is congruent to CBP. Okay. Now, if I were to turn this around, this angle here and this angle here, they would be congruent. So we've got angle APQ. APQ is congruent, APQ, to CQP. And that's 3 of the 4. And then this one right here, I'm going to put 2 dots there. That's not really geometry, but I just wanted to show you. These 2 are going to be congruent. So we're going to call that BPQ is congruent to, let's see, BPQ and DQP. Okay, so I've got the 4 lengths, the 4 side lengths that are corresponding and congruent, and I've got the 4 angles that are corresponding and congruent. That was a lot. All right, let's look at 3. ABCD is a kite whose diagonals intersect at P. So this is a kite, and a kite has adjacent angles, or adjacent sides are the same length. Adjacent sides, so that means that CB and CD, they're adjacent, and because it's a kite, they're the same length. And then BA and AD, they're adjacent, so they're the same length. So you've got 2 short sides and 2 long sides that are the same length. And then it says they're diagonals, so intersect at P. And where they intersect, when you have a kite, they intersect, they make right angles. So you have 4 right angles. Now, the interesting thing about a kite that we did not write down is that this long diagonal bisects the short diagonal. What that means is the long diagonal cuts the short diagonal in half. Exactly. So BP and PD are the same length. So these are the same length. Okay. So then we have, it says, name all possible pairs of figures that are congruent. For each pair, name the corresponding congruent line segments and angles. This is a lot. Okay, all possible pairs of figures that are congruent. Now, I am seeing a small triangle, 2 small triangles, and they would be congruent because we've got these 2 side lengths are the same. This side length is the same. Well, they share PC, and since they share that side, that is the same length. So we have 3 side lengths that are congruent for each of them. So let's look at the first pair is this triangle. I'm going to call it CPB. Triangle CPB is congruent to triangle CPD. So then it says, so this is the first pair. That's pair number 1. All right, let's do our congruent side lengths. So these 2 are congruent and they are corresponding. So CB and CD. CB is congruent to CD. That's one of them. BP and DP are congruent. BP is congruent to DP. And then CP and CP is congruent to CP. So that should be straight. 3 congruent side lengths, so the triangles are congruent. Now that means that the angles are congruent. So we've got 3 different angles. We've got these right angles here, BPC. So angle BPC is congruent to DPC. Angle DPC. And then we've got, all right, then these 2 out here, imagine if I folded it up. These 2 angles would lay on top of each other. They're congruent. So that's going to be PBC. Angle PBC is congruent to PDC. And then because they're congruent, these angles right here, this one and this one have to be congruent. So we're going to call that BCP. BCP is congruent to DCP. Okay, so that's the first pair, these small triangles, the 3 side lengths that are corresponding and congruent, and then the 3 angles that are corresponding and congruent. Then we've got these triangles right here. This is our second set. So we've got triangle ABP is congruent to triangle APD. Okay, that's pair number 2. All right, again, the side lengths that are the same length. Well, we've got these 2 that are corresponding the kind of the shortest side. So we'll call that BP and DP are congruent. BP is congruent to DP. Then we got the ones with the 2 hash marks, AB and AD are congruent. AB is congruent to AD. And then this one they share. So AP and AP are congruent. All right, so those are our 3 side lengths. Now our 3 angles that are congruent. We got these right angles down here. So BPA and DPA, these 2 are congruent. Angle BPA is congruent to angle DPA. Okay. Then let's see, we've got this one down here matches this one up here. Those 2 are congruent. So we're going to call that ABP and ADP. Okay, ABP angle ABP is congruent to angle ADP. Okay. So we did these 2. Now these 2 right here are also congruent. So we'll call that BAP, BAP, and DAP. BAP is congruent to DAP. All right, that's pair number 2. 3 side lengths that are congruent and corresponding, and 3 angles that are congruent and corresponding. Now, do you see the last set that are? Well, it's this triangle, ABC, so the big one, the biggest one, and CDA. So the third pair and the final one is triangle ABC is congruent to triangle ADC. All right, what I want you to do is finish this one. Tell the 3 side lengths that are congruent and tell the 3 angles that are congruent. So do that for number 3. A lot going on this page. All right, number 4. ABCD is a rhombus whose diagonals intersect at P. Explain using a test for congruent triangles why triangle PAB is congruent to triangle PCD. I'm going to take my highlighter and highlight the two triangles we're talking about. PAB and PCD. Here's PAB, this one. PAB. And PCD. Okay, why are these congruent? So we have to prove that. And again, we can prove it by proving all three side lengths are the same. We can prove it side angle side, etc. All right, there's a few things. We have to use the properties of a rhombus to help us work this out. And one of the properties of a rhombus is that all four side lengths are the same length. So CB is the same length as CD, CD, which is the same length as DA, which is the same length as BA, okay? So we know that at least in this triangle, these two sides are the same length, okay? We also know, there's a lot that we can do. We also know that when you have diagonals of, you may not know this, but the diagonals of a parallelogram, ABCD is also a parallelogram because the top and bottom are parallel and the two sides are parallel. So it's a parallelogram. And when you have a parallelogram and you have the diagonals, these two diagonals, they cross right in the middle of each of them. They what we call bisect them. So what that means is we've got one of the diagonals is from B to D. Whoops, I'm covering. B to D is one of the diagonals. P cuts BD in half, which means the length from B to P and from P to D are the same. It cuts it in half. Well, it does it the same way going the other way, okay? So AC is cut in half right here, okay? So I know now I've got three triangles that are the three side lengths that are the same. These two are the same. BP and PD are the same, and CP and PA are the same. So the test we used was side, 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 okay? So we know that BA is congruent to CD because a rhombus has four congruent side lengths. We know, so that's one of the two of the sides. We know that BP and DP are the same. Hey, what am I doing? All right, BP and DP are congruent because P is the midpoint of BD. Okay, so it cuts it in half. And then we can do the same thing for AP and CP. AP is congruent to CP because P is the midpoint of AC. All right, and because of all that, they have three side lengths that are the same length, so they have to be congruent. All right, number 5. I'm going to get you started, but I want you to finish on your own, and I'm barely going to get you started. A, B, C, D, E, F is a regular hexagon. Now, this word regular is very important, and it is telling in here. Any figure that is regular, a regular hexagon, a regular pentagon, a regular octagon, what that means is it's kind of like a square. A square, all the sides are the same length. A regular hexagon has all sides are the same length. So AB is the same length as BC, which is the same length as CD, which is the same length as DE, which is the same length as EF, which is the same length as FA. So all the sides are the same length, okay? It's got these diagonals, and it's telling you that AC and AE are congruent. So it's got the two hash marks to tell you that they're also the same length. Now, A says name two pairs of congruent triangles. For each pair, justify the congruency with a test. So are you going to use the three side lengths? Are you going to use side angle side for congruent triangles? Then it says name a pair of congruent quadrilaterals. I'll give you a hint. This right there divides it into two congruent quadrilaterals. All right, folks, I want you to finish number 3, and I want you to do number 5. And when you do that, this whole assignment should be done. And we will look at part 2 next time. Have a great day. Bye.